So this is a review of the scientific process and how to design an experiment lecture that I went over in class a few days ago. So by the end of this lecture, you will be able to explain the scientific process, design an experiment using the scientific process, differentiate between a hypothesis, a theory, and a law, and finally explain what pseudoscience is and describe where pseudoscience exists. So let's go ahead and go over what the scientific process is. It is a way to ask and answer scientific questions by making observations and doing experiments. It is a 6-step process. It begins with asking a question, and then you do some background research. Then you construct a hypothesis. Then you test your hypothesis by doing an experiment. You analyze your data and draw a conclusion. And finally, you communicate your results. So first, you ask a question. The scientific method starts when you ask a question about something that you observe, and it goes along the lines of how, what, when, who, which, why, or where. And in order for the scientific method to answer the question, it must be about something that you can measure. It's really important to know that it must be about something that you can measure, whether it be numbers or some sort of physical change or something along those lines. It must be measurable. And next, you're going to go ahead and do some background research. You want to be a savvy scientist by using library and internet research to help you find the best way to do things and ensure that you don't repeat mistakes from the past. It'd be a bummer to do something over again and realize that all the time and energy that you put in, someone already did something like that. Then you construct a hypothesis. A hypothesis is an educated guess about how things work, and it uses this format. If I do this, then this will happen. You must state your hypothesis in a way that you can easily measure. So now let's test your hypothesis by doing an experiment. Your experiment tests whether your hypothesis is supported or not, making sure that you change only one factor at a time while keeping all other conditions the same. Let me repeat that. You change only one factor at a time while keeping all other conditions the same. You should also repeat your experiment several times to make sure that the first results weren't just an accident. And next, you want to analyze and conclude. Once your experiment is complete, you collect your measurements and analyze them to see if they support your hypothesis or not. Then, if and only if your hypothesis was not supported, you want to construct a new hypothesis based on the information you learned during the experiment. And this starts the entire process of the scientific method over again. And even if you find that the hypothesis was supported, you may want to test it again in a new way. And finally, you communicate your results. Communicate your results to others in a final report and/or a display board. Believe it or not, professional scientists do almost exactly the same thing by publishing their final report in a scientific journal or by presenting their results on a poster at a scientific meeting. So, let's go ahead and review. First, you ask a question. Then you do some background research. Then you construct a hypothesis. Next, you test with an experiment. You want to ask yourself, is my procedure working or not? If it is, you can continue and analyze data and draw conclusions. You want to ask yourself, do my results align with my hypothesis? Or do my results partially or not at all align with my hypothesis? If they do align, you want to communicate your results. Now let's say your procedure is not working. You want to troubleshoot the procedure and carefully check all steps and setup and maybe change some things if you need to. And now let's say your results align partially or not at all with your hypothesis. You want to go back up and construct a new hypothesis and start all over again. Now there's 3 words that are very important to know in the scientific process. And you hear these all the time, whether it be in scientific literature classes and whatnot, or even in everyday occurrences. So the first one is a theory. A theory may be formed after many related hypotheses have been tested and supported with experimental evidence. It is a broad and comprehensive statement of what is thought to be true, and it is supported by considerable evidence, and it ties together many related hypotheses. And next is a law. It is a statement of fact that concisely explains an action or group of actions, such as the law of gravity. It is accepted to be true and universal, and it may be expressed as a mathematical equation, such as E equals mc squared. You've already learned about a hypothesis, which is an educated guess. Now, let's see how good you are. Let's find out if the following are a hypothesis, a theory, a law, or none of the above. Here's the choices. If I put red food coloring in this water, people will not drink it. Evolution, gravity, and I have a theory that some people are not listening to me right now. Go ahead and take a minute to find out what you think might be the answer. Alright, so let's start with the first one, which is if I put red food coloring in this water, people will not drink it. If you guessed hypothesis, you are correct. It goes along with the format, if I do this, then this will happen. If I put red food coloring in this water, people will not drink it. Evolution is a theory. It is not universally accepted, and it has not been proven to be true yet. However, it is a comprehensive explanation of many hypotheses. And then there's gravity. Gravity has been universally accepted. And then finally, this one, I have a theory that some people are not listening to me right now, is none of the above. People say this all of the time. I have a theory that it's going to snow today. I have a theory that there's ghosts in my house. It is not the same theory that we use in scientific process. Now let's do one more set, and this one's going to be a little bit harder. So, if a butterfly flaps its wings, a hurricane will happen in Japan in 5 years. If I eat 200 M&Ms, I will be able to do 50 jumping jacks. And then there's this theory that it might rain today. Go ahead and take a minute to find out what these answers might be. Let's see if you were right or not. So, if a butterfly flaps its wings, a hurricane will happen in 5 years. If you guessed hypothesis, you are actually incorrect. It is none of the above. There is no way to measure if a butterfly flaps its wings, a hurricane will happen in Japan in 5 years. There is no possible way with the technology we have right now to test that. Therefore, it does not fit the mold of a hypothesis. If I eat 200 M&Ms, I will be able to do 50 jumping jacks. That is a hypothesis because I can measure that, and it follows the mold of if I do this, then this will happen. And finally, there is this theory that it might rain today. That is none of the above. Again, incorrectly using the definition of a theory. Now, we did the scientific process, and now we're going to go ahead and design an experiment. There are some important components of an experiment that you need to know about before you can design an experiment. They are a variable, which is what you are testing, a control, which is a separate part of the experiment that does not receive any of the variables. It's controlled. Nothing happens to it. There's an indicator if your test subject is actually changing due to variables or not. And finally, there's the constants, the variables that do not change throughout the experiment. It remains constant, nothing changes. So now let's go ahead and say we went ahead and did experiment. We designed one. So, you're very curious if this new energy drink can keep students from falling asleep in class. So you design an experiment to test out your hypothesis that this energy drink does in fact keep students from falling asleep in class. For the experiment, you decide to use 10 of your best friends who agreed to do this beforehand since you are very ethical. 5 of your friends will receive 1 energy drink before class. 5 of your friends will not. To make sure your data is accurate as possible, you make sure each of your friends receives only 6 hours of sleep before class. So now let's see what is what in this experiment. We have the group of friends, energy drink, consumption, group that doesn't drink, the same amount of sleep between friends, and whether or not your friends are falling asleep in class. Go ahead and take a minute to figure out what is what, and we'll go ahead and review. Alright, let's see if you're correct or not. So, your group of friends, is it a variable, control, constant, or none of these? There's actually none of these. They are just a test subject. Energy drink consumption will be a variable. The group that doesn't drink will be your control. The same amount of sleep will be a constant. And finally, friends falling asleep or not is also a variable. Now, there's something important to note about variables. There are 2 types of variables that exist out there in experiments. There's the independent variable, it's the factor that you will manipulate for your experiment. And then there's the dependent variable, that is the indicator that your experiment is working or not. So, let's go ahead and see what is what. Is the energy drink consumption independent or dependent? And is your friends falling asleep or not independent or dependent? Go ahead and take a few minutes to figure out if what you think is correct, and we'll go ahead and review. Alrighty, so if you said energy drink consumption is independent, you are correct. And if you said friends falling asleep or not is dependent, you are also correct. Now there is an easy way to remember this, since even I get this mixed up a few times. The independent variable causes a change in the dependent variable, and it is impossible that the dependent variable could cause a change in independent variable. So using our example, energy drink consumption causes a change in students falling asleep in class, and it isn't possible that students falling asleep in class could cause a change in energy drink consumption. Now there's one more thing, it's called pseudoscience, and there's this awesome Bill Nye video. If you follow the link right here and go to YouTube and watch this, you can better understand what pseudoscience is. Bill Nye explains it way better than I can. And that concludes the lecture on the scientific process and how to design an experiment.